Hello everyone. In today's class, we will discuss about a bubble sort. Okay, let's take an array with 96432 elements. Okay, let's discuss the steps. Okay, here the approach is we have to keep comparing adjacent elements. Okay, suppose we have to compare the first element with second element. If the second element is greater than first element, let's swap it. Okay. Likewise, again, keep continuing it till the biggest element reaches to the end of the array. Okay, so like this, we have to perform no, multiple steps. Let's start with step by step. So in the first step, let me start with first step. The elements are 9, 6, 4, 3, 2. Okay, so let's compare 9 and 6. Since 9 is bigger than 6, let's swap 2. So 6 will come to first place and 9 will in second place. Remaining same 4, 3, 2. Fine. Now let's compare next two elements. These two. 6 since 9 is greater than 4, swap it. 4, 9, 3, 2. Okay. Next compare 9 and 3. 6, 4 since 9 is greater than 3, so swap it. 3, 9, 2. Next compare these two elements. So 6, 4, 3. So again 9 is greater than 2. Let's swap it 2, 9. Okay. This is the first step. If we observe the first step, so 9 is okay reached to the last position, which means it's already sorted. So we place the biggest element at the last position. 9 is swapped. Okay. Now again take this array, modified array, perform the same swapping approach in second step. Okay, now the input array is 6, 4, 3, 2, 9. Compare first two elements. 6 is greater than 4, so swap it. 4, 6, 3, 2, 9. Okay, next compare 6 and 3. So 4, since 6 is greater than 3, swap 3, 6, 2, 9. Next compare these two. 4, 3, 2, 6, 9. Okay, since 9 is already sorted, we no need to check this. Okay, we can stop here. So now, which two elements are sorted? These two elements are sorted now. Okay, initially only one element is sorted in the first step. In the second step, two elements are sorted. Okay, now perform the third step. Okay, now take this as a input. What is the input? 4, 3, 2, 6, 9. Okay, 6, 9 is already sorted. Okay, we have to compare only the first three elements. So first two. Okay, since 4 is greater than 3, swap it. 3, 4, 2, 6, 9. Next I'll compare 4 and 2. 3, 4 is greater than 2, right? So 2, 4, 6, 9. So already 6, 9 is sorted. We no need to compare. Okay, now with the third step, last three elements are sorted. Okay, so first step only one element sorted, second step two elements sorted, three elements, last three elements are sorted. Now let's start with fourth step. Okay, in the fourth step, let's take this input array. 3, 2, 4, 6, 9. Okay, so let's compare only this no need to compare, already sorted. We have to compare only this 3 and 2. Since 3 is greater than 2, let's swap it. 2, 3, 4, 6, 9. That's all. So now last these four elements are sorted. 3, 4, 6, 9. Now remaining element only one element we have. This is anyhow no need to compare. It's already sorted. So the final output is 2, 3, 4, 6, 9, which is sorted. Got it? This is the bubble sort algorithm approach. Okay. So a few important points if you observe. So what is the size of the array here? Okay. Here size of the array is 1, 2, 3, 4, 5, 8. So the size of the array is 5. Okay. How many steps we did to swap? Only 4 steps, which means we have performed n minus 1, correct? And every step, in the first step we sorted one, in second step, okay, we didn't compare, okay, we ignored the 9, we did, okay, we have done only till 4 elements only we compared, okay. In likewise, we here 1 is sorted, here 2 is sorted, here 3 is sorted, 4 is sorted, correct? We are not comparing all the elements in every step, we are reducing comparisons, correct? Fine, these two observations are important to implement the logic. Fine. So how to write the logic for it is, we have to use a two for loops, okay. One for loop is, okay, one first for loop is to iterate I equals to 0 to n minus 1, correct, till n minus 1, 1 2 3 4, 4 steps, okay. We have to take one more for loop, okay, for comparing and swapping, correct, that is j2 till we have to n minus 1 only, okay, because the last element we are ignoring. Again, in the every step we are ignoring already sorted portion, right? That is minus I we have to write, okay. Here we will write a logic if array of j is greater than array of j plus 1. If it is greater, write a swap logic, okay. This is the simple pseudocode, okay. Let's write this code in Java, and let's execute this. So as input here, I just took 100, 90, 80, 70, 60, 50. Okay, let's write a simple user-defined method, bubble sort. Okay, I am passing input as array, and also I am passing its length. Fine, and public static void bubble sort. Let's define an array, comma. Let's take size as n. Okay, and also let's print the elements after sorting. After sorting, so arrays dot toString of the input array. Got it? Now let's implement the logic for int I equals to 0 till n minus 1, because in last step we are not comparing we are not checking the first element, right? And I plus plus, one more inner for loop, int j equals to 0, j less than n minus 1 minus I, because we are ignoring the sorted portion, right? And j plus plus. Now compare if the first element is greater than its adjacent elements. How to check adjacent element? J plus 1, its neighbor. Okay, if it is greater, let's swap it. Okay, int temp equals to a of j, and a of j equals to a of j plus 1, a of j plus 1 equals to temp. Done. Okay, so let's run the program. So after sorting, we got it. Okay, now a few important points we need to understand the time complexity. Okay, what is the time complexity here? Because since we are using a two loops here, and this will take order of n. Again, this will also take order of n. So the time complexity in normal logic is so order of n square. Correct. So this is if array is not sorted. For example, if we have input which is already sorted. For example, we got input 1, 2, 3, 4, 5. Okay. This time, okay, we can just modify a little bit our algorithm, to reduce the time complexity. Instead of order of n square, we can just reduce this time complexity to order of n. This is the best case, correct? If already if we input array is already sorted, okay, how we can do that is just you write a small check here. Let's take you can take a boolean variable. Just I'm taking int on variable flag. Let's initialize with flag equal to 0. Okay, so here, right, if swapping is happening, then I'm making flag equals to 1. Okay, so if swapping happening means the array is not sorted. Okay, if this if condition is not at all executed, not even once, means this array is already sorted, correct? So this time we will break it. So here we already make flag equals to 1. When flag equals to 1, if array is not sorted, if array is already sorted, flag remains 0. Okay, once this inner loop completed, just come out of only inner loop, and if flag is still 0, which means all elements are started, just break it. It will come out of outer loop also. Okay, just run it. Okay, so this is the best case time complexity. It will come to order of n. Okay, and space complexity is order of 1. We are not using any extra space, so space complexity is order of 1. Okay, thanks for watching this video.